Hello students, welcome to the subject design pattern, course code SCD 304. The topic which we are going to study is adapter design pattern. In this lecture, we will cover following contents. Firstly, we will start with the introduction, then intent, motivation behind of using adapter design pattern, few examples from application as well as real world level, the participant classes, and the variation of adapter pattern, then UML representation and code implementation of any problem. After learning adapter design pattern, you will be able to handle the incompatible issues among different libraries and interfaces in your application, and it will also help you to reuse old toolkit or existing library to integrate in your application. Let's start with the introduction. The adapter design pattern falls in structural category. The pattern involves a plug-level class, a wrapper class, which is responsible to join functionalities of independent or incompatible interfaces or classes. Just to understand, take an example of any adapter in the real world, as it is used to connect the two interfaces or two systems which are not compatible. So, by using the adapter, you will be able to use two incompatible system, two incompatible classes to use them together. So it acts just like a bridge between uh, two incompatible objects. In the real world, we have adapters for power supplies, adapters for support of different memory cards in our laptop and in different devices. So if you cannot plug the camera memory in your laptop, you can use an adapter. You plug the camera memory in the adapter, and the adapter will be connected to your laptop slot. So by using the adapter, you will be able to connect two unknown, unseen, and incompatible interfaces together. Adapter design pattern converts the interface of a class into another interface that client expect. By using the adapter or the pluggable class, it lets the classes to work together that couldn't otherwise because of their incompatible issues. The basic purpose of adapter is to convert the interface. It actually it actually doesn't change the existing class or the interface, but it wraps the existing class to make it compatible for the new interface. So the adapter design pattern is also known as wrapper. The example of adapter design pattern is from real world. Just take an example of a capsule. Like it's difficult for you to eat or to digest the medicine because of its bad taste. So mostly doctors put the medicine or the powder inside a plastic capsule, and you can easily swallow that capsule, and easily you can engulf it and intake it. So it doesn't change the chemistry, the functionality of medicine, but it wraps the medicine so that you cannot feel the bad taste. So it makes easier for you to digest that medicine. Similarly, the purpose of the adapter design pattern is to make the two incompatible interfaces or the classes compatible for each other. To understand the adapter design pattern in simplest and easiest way, look at this diagram. In this diagram, you can see there are three different blocks. The morphology, the structure of these three blocks is different. Uh, the first block is the client block, and the third is component. Let's say you have to use the client block and the component block together. You have to connect it. So it's not the one solution which will comes to your mind is you change the existing structure or morphology or the style of these two blocks to make them use together. But it's not a good idea to change existing functionality will destroy its existing functionality. So instead of changing the existing classes or existing interfaces or existing system, the better solution is to introduce a third, a middle, a bridge, or a wrapper. As you can see that in center there is a second block which is labeled as adapter. This piece of block is compatible with the block which is client or the client interface or the client system, and it is also compatible with the component or the target block. By introducing this piece of adapter, you are able to connect the client block and the component block. The client block is the client class or the client interface, and the component block is the target interface or the target class. So you want to use them together, but because of the differences in their structure, they are incompatible and you cannot plug them or you cannot connect them together. So the adapter provides a solution of connecting and using the two different interfaces, two different classes, two different systems, to use them together by wrapping into a wrapper or adapter. Similarly, let's say an example, when you travel from one country to another country, let's say you are traveling from US to Europe for the first time, you may get a surprise, or you may find a problem while trying to charge your laptop, because the power plug and the socket standards are different in different countries. So that's why your US plug won't fit a German socket. The problem can be solved by using a power plug adapter that has the American style socket and the European style plug. So you cannot plug or introduce a new like into your existing charger, and similarly you can change the socket board, but the solution but the solution is more easy and convenient to use the adapter or the third interface which is compatible for the charger plug and all, as well as the circuit board. Similarly, you find different kind of hardwares or existing devices that you cannot plug them together because of the differences in their structure, their morphology. For example, when you try to connect your laptop with a multimedia, it requires HDMI converter because the multimedia is not able to provide the port for connectivity of a VGA port to your laptop. So you use the HDMI converter. Similarly, sometime your TV or your LCD is not able to connect the TV tuner card, and again you will use the adapter, because you cannot change the structure existing structure of your laptop or the any other external devices which you want to connect. So the solution lies in using a third interface or the third wrapper, which will be known as adapter. Another example of using the adapter classes or the adapter interfaces at application level is that when you try to connect the direct database like Oracle, MySQL, or Sybase to your any application which can be written in Java or PHP, you cannot connect it directly. So you have to install and you have to configure the drivers or different utility programs. These drivers will help you to connect your piece of code or your Java application or your API with the databases, because the databases and your code file is different in their structure and you cannot change the existing APIs. So the best solution is to use the adapter classes or the third wrapper classes, and these are all the example of adapter design pattern. After getting the basic introduction of adapter design pattern and seeing the example from real world and as well as application level, now you can easily understand the basic intent of this pattern. This pattern converts the interface of a class into another interface that client expect. Adapter lets the classes to work together that couldn't otherwise because of their incompatible interfaces. As we have seen in the previous example, that when we have two different interfaces, two different classes that we cannot use together because of differences in their structure, then instead of changing the existing classes, existing libraries, existing APIs, the best solution is to introduce a third class or third wrapper or third system or third interfaces which will recognize the client class or the client interface and as well as the target interface. And using the adapter, you will be able to connect the client interface with the target interface. To understand the motivation behind of using the adapter design pattern in your application, you may find a scenario that you have to use or integrate toolkit or any library in your application, but you cannot use that existing toolkit or existing library because its interface or structure is different from your piece of code or your application, because might be the toolkit doesn't support the language in which you are developing. So the toolkit and your piece of code or your application is not compatible. That is required by your application. So the solution which you can firstly think is to change the library interface or to change your source code, but it's not a recommended solution by the experienced software engineers, that you cannot change the existing library code, because the one reason is that you may don't have its code, or you don't have the permission to change the code of the third party API or library, or sometimes if you have the source code but you cannot change it because of its already existing functionality it's meeting, because if you change its code then you can produce the regressions or you can disturb its existing functionality. So the best solution is to support such different interfaces. You have to introduce, you have to write, or you have to design a third third interface or the third class which is compatible for the unseen interfaces. This is the generic UML representation of adapter design pattern. In this diagram, you can see that the client wants to use or connect the target interface and the adaptee. Target is the interface or the class or the system which you want to use, and adaptee is the interface that needs to be converted. So instead of changing the target interface or the target class and changing the existing adaptee class, the best solution is to write or design a third adapter or the wrapper class. The adapter class will be able to connect the target and as well as the adaptee class, and using the adapter class the client will be easily handle the incompatible issues between the target and as well as the adaptee. To implement the design pattern, firstly you need to understand the important classes which are known as the participant classes. The participant classes in adaptive design patterns are the first target class. Target is basically the class which defines the domain specific interface that client want to use, and the second is the adapter. The adapter class or the adapter is the wrapper which will help to wrap the adaptive interface so that it can be used with the target interface. And third is adaptee. Adaptee is a third class or the interface which the client want to connect with the target interface. So it defines an existing interface that needs adapting. And the client class is the class which collaborates the object conforming to the target interface. There are basically two ways and two solution to implement the adaptive design pattern in your application. The one form or the one way is known as class adapter. In this way, you have to implement or you have to use the multiple inheritance to compose your classes. As you can see in this UML diagram, that the target interface and the adaptive interface is both are both the parent of your the new adapter which you are going to write or design to connect the target interface and the adaptee. In this diagram, the target and the adaptee are the two incompatible interfaces, and you cannot use them together because of the differences in their method, their functionality, and their structure. And you cannot change, and or it's not a good solution to change the existing target and adaptee. So you have to write or you have to design a new class which will be implemented by both the target interface or as well as the adaptive interface, and the client will simply request the adaptive class to invoke any functionality from the target and as well as adaptive, because the adapter has access to both interfaces. So this is the first form of your adapter design pattern, and it is known as class adapter. The second way or the second solution to write the adapter or the wrapper class in your application is known as object adapter. The first solution has some limitation. As we know, there are certain languages and different languages that not support multiple inheritance. In those languages, you have to use this approach of object adapter. Object adapter basically use the compositional technique instead of multiple inheritance to adapt one interface to another. You can see the change in this diagram or UML representation is that the new adapter class is implementing the target class, but it has the object of adaptee. So it has both the composition and as well inheritance. You can see that adapter is not having the parent of adaptee, but it has excess of instance or the composition technique to access the or to connect the two incompatible interfaces, that is a target and adaptee in this scenario. So you will use this object adapter way when your language does not allow you to implement multiple inheritance. Now to understand the implementation of adaptive design pattern as code level, let's take the example of a scenario. Let's suppose we have three mobiles as the one is Nokia Asha, the second is Nokia Lumia, and the third is Samsung 3. You know that each company mobile has different kind of charger, but now with the increasing technology, the companies are providing different hardwares and the connectors using which you can charge all your mobile instead of or regardless of different chargers. You simply have to plug that the third device or the third adapter or the third hardware, which will make any mobile from any company, and you can charge it with any charger because of that third adapter. So we will implement it as an application level. In this application, we will charge all the three mobiles with the same Nokia charger. Let's assume that we are given only with the Nokia charger and we want to charge all the Nokia mobile and the Samsung mobile with the Nokia charger. It's not possible in first way because they have differences in their structure. In order to charge the Samsung mobile with the Nokia charger, we have to write a third interface which will act as an adapter plug, and it will connect the Nokia charger and allow the charging of Samsung mobile. As you can see in this diagram that the both Nokia mobiles can be connected with the Nokia charger for invoking the functionality of charging, but the Samsung mobile will only be connected with the Samsung charger. But we want to charge or we want to use the same Nokia charger to charge the Samsung mobile. So instead of changing the Samsung functionality or changing the Nokia charger functionality, we will write adapter plug class, and using this adapter plug class, we can connect the Samsung mobile and the Nokia charger with each other. So it will resolve the issue of incompatibility between two different interfaces. So let's start with the first class, which is the chargeable interface. This is our target class, or this is our target interface. We can see there is one method here which is performing or allowing the charging functionality. Similarly, the next class is the Nokia Asha class, which is implementing with the chargeable class or the chargeable interfaces. Inside this class, there is a definition of the charge method for just to keep track of flow of our information. We have using the SOP or the logging technique. Inside this method, basically, you can implement the charging functionality. Similarly, the second Nokia mobile or the Nokia mobile class is also implemented with the chargeable interface or the target interface, and inside it the charge method is overridden with its written definition. And you can see that there is the third class for Samsung mobile is the Samsung 3 class name, and it has its own charging method which is Samsung Charge, and it has the definition of its own charging mechanism. And you can see the difference in this class and the Nokia class is that the both classes have implemented with the chargeable class, so they can use this charging functionality of the Nokia charger. But in this class, you can see that it's not implemented with the chargeable class, so you cannot use the same chargeable class charge method to invoke the charging functionality. So now we have to charge this class or charge this mobile with the same chargeable interface, but because of the differences in their structure or their methods, we cannot invoke the charge method of chargeable class. So you might think we can, or we will change the Samsung class or the functionality of chargeable class, but just to recall that it's not the recommended approach to change in the existing classes for your current domain specific problem. So we will solve this problem by writing the adapter class. This is the adapter class that we have written for using the charging method of chargeable class into the Samsung. This adapter class is implemented with the chargeable class, which method we want to use, and we want to connect the chargeable method or chargeable interface with the Samsung. So we have also declared or instantiated the instance of Samsung class. You can see that this plug or this wrapper or adapter is implemented with the target interface, which is chargeable in this case, and it has the second technique, which is the composition technique of the adaptive class, which is Samsung in this mobile. So you can see that we have using the second approach or the second form of adapter design pattern, as we have discussed earlier, that few languages does not support the multiple inheritance. So instead of implementing the adapter class with both the target class and as well as the adaptive class, in second way you can implement your adapter with the target interface, and you can compose the instance of adaptive class inside that adapter, like we are doing in this code. And in this constructor method, we are simply setting the instance of Samsung 3 with passing the env parameter. After implementing this class or the adapter class with a chargeable interface, we can implement the charge method as we have done in the Nokia classes. Inside the charge method, we are invoking the required functionality of our adaptive class here. You can see that using composition, we have referred the instance of Samsung class, and inside this charge method, we are invoking the functionality of Samsung charging functionality. So using this method, we have defined the, or we have invoked the charging functionality, that when we have implemented it using the second form, we can easily use or override the charge method. The third method is simple. Any other method to string, it shows that your adapter class is a normal class. You can write the other methods, or the you can define the other functionalities here as per the requirement of your application. Now this is the run chargeable class, which is the client class. Using this class, we will check that we have implemented the adapter design pattern. In this class, you can see that inside the main method, firstly the instance of the first class, which is Nokia Asha, is created. The second Nokia Lumia instance is created, and the third is Samsung 3 instance is created. And in next line, you can see that we have also creating the instance of our plug or our adapter class. Inside this constructor, we have passed the reference of our adaptive class, which in this case is Samsung S3. By passing the reference of adaptee, you can connect it with the target interface. And in the next line, you are seeing that the Nokia Asha is calling the charge method, the Nokia Lumia is calling the charge method. You cannot directly call the Samsung 3 dot charge method. So to resolve this issue, you are calling the adapter instance, and by referring the adapter class, you are able to call the same charge method of the chargeable class. And you can see that now you are using the same chargeable class to charge the both not only the both Nokia mobile as well as the Samsung mobile. So by implementing this adapter class, you are able to connect the Samsung interface and as well as the chargeable interface. So you can see that how we have resolved this incompatible classes issue by just simply writing the third adapter class. After running this application, the following output will be displayed by the console. You can see the flow of your application. that using the same charger class method charge, you are able to invoke the charging functionality of three different mobiles with the same chargeable class or the chargeable interface. Basically, you are not changing the Samsung class, you are wrapping it inside the adapter class, as we have seen in the previous code. That adapter class is just wrapping the adaptee class, and by wrapping it, it's changing its structure and the morphology and making it compatible with the requirement of your target interface. So after seeing different examples at application level and as well as real world level, we have learned that the adaptive pattern is very important, and it is used to connect the two incompatible interfaces, classes, or the system together. We can use them. So adaptive pattern improves the structure by wrapping the existing class or the interface, and by wrapping it, it enables it to use it with the incompatible target class.